Hey everybody, this is Larry. This is day 5th of the December Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem today, Can Place Flowers. So I do solve these problems live, including thinking about the explanation. So feel free to feel free to play this back at faster speed or skip to the solutions at the end, because I usually explain my thought process, not just the solution, as well as I'm going through it. So today's problem is Can Place Flowers. You have a long flower bed. Some have plants, some don't. Flowers cannot be in adjacent plots. So there's zeros and ones. And flowers so okay. So this is gonna be greedy. Yeah, so I think this is just gonna be greedy. Basically, so I would say there are a couple of things, right? Greedy problems, or greedy solutions rather, are always tricky for me, even now, because you have to prove them correct. And in my mind, I'm just thinking, okay, how do I even begin to explain it, right? I mean, I actually know that this is greedy, just from some invariants that I've been experiencing with. But explaining that is not quite easy. But the idea is that, okay, in this case, I would go through an exhaustive kind of argument, because basically you have the case that I think I had a 4 or 5 maybe, but let's say we use 5 as an example, right? The optimal is always going to be, either 1 or 2 of these things, right? And here you can clearly see that the optimal will be here, and it doesn't. And there are obviously more combinations, but the other combinations don't make sense. So let's say this is the input, and we don't have adjacent flower beds or flowers. You always want to do consecutive, because the tighter you squeeze them together, the better it is, right? I think that makes sense. And it doesn't make sense to have fewer than the most that you can, right? So then in that case, so you want to squeeze them together, you want to be greedy because you want to compress them as much as possible. So that given an input, and I choose the 5 deliberately, because I think that's the first case where you get to see this pattern, because with 4 you just kind of see a subset of these patterns, and with 3 other things happen, right? So so that's basically how I would think about this. And there actually now becomes 2 ways of implementing it, whichever you like. And if I am trying to do this really fast, I would actually use group by and then do the math on the number of spaces, because you can see that for every 2 spaces, this is for n is equal to 2, right? And you could kind of see that logic very clearly with 5, but for any arbitrary n, you just basically do the greedy, and it becomes an implementation problem, as I said, because then looking at the ones, we just kind of and there are trick cases with the edges, right? So there are a couple of edge cases here. There's now for this input, you have to look at the inside to be like, okay, what does the inside means, right? Well, the inside means that given 3 contiguous 0, that means that the left n are not good and the right n are not good. So basically, let's say we have 10 0. Well, in this case, this is 3 zeros, but let's say we have 10 zeros. That means that the left n is not good, no good, no good, and the right n is no good. So that means that it is 10 minus 2n, or if you want to generalize it, let's say we have k zeros, we now have k minus 2n good zeros, in which we can start at the first one and then we can space them out, right? And then this becomes a mathematical formula, obviously, and you could do it that way. There's also another way to do it, which is with how do you say this? With greedy, just by implementing it, you could basically keep track of the last one on the left, and then you can also do some suffix counting of what's the next one to the right, and then that will allow you to be greedily like, hey, can I put a 1 here? Can I put a 1 here? Can I put a 1 here? Right? On every forward part, and allow you to answer that question. And in terms of implementation, the faster way would be just to get those groups of zeros, and I think and it depends on how you want to do it, because I think there may be more potential for me anyway, because I'm bad at math, at least like algebra. I'm bad at algebra, and especially if off by once, but yeah, I'm going to do that. So let's go do this way. And also, if I'm doing this in a speed run kind of way, in a competitive fashion, I'll probably use the function like group by and illustrations. Your library might have different similar things, but that's the way that I would do it. But for now, let's do it this way. So total is the number of planet ones. Actually, I think I just solved the wrong problem. So, well, I got confused with the n. Okay, so yeah. I might have to record this. I think I had to know adjacent rule initially want correct. Okay, so actually, let me retract some of this video. My apologies, because for some reason I thought it said no next n adjacent ones, and then return the max or something like that. But actually, it's just no adjacent ones. So what I said initially was true, but then I think I just got a little bit confused reading the problem. So then you can just go for it one by one, and then see if we can place them clearly, right? So yeah, let's do it that way. It is greedy. Let's get n is equal to the number of flower bed. That's a little bit confusing. Let's do this as k. I think the n confused me a lot, but yeah, sorry friends that I kind of explained a problem which you can upsolve at home, but it is not this problem. But yeah, but now going back to the original problem where our k is equal to 2, I guess, or with one space, but 2 apart, or maybe k is equal to 1 where k is equal to 1 space. Then then we're able to figure this out in a this is a more easier problem, and we can be very specific about it. But yeah, for now, for index in range sub n, so if index minus 1 is greater than 0, and forward bed of index minus 1 is equal to 1, then we continue because we don't want to put it here. Or if, well, I guess if forward bed of index is equal to 1, we also cannot put it here. Also, the other case is if forward bed of index plus 1 is equal to 1. Oops. We continue, right? So basically, those are the only 3 cases. As I said, if we had to look more than just the adjacent one, we would do techniques that we were talking about with either the math or using some kind of suffix lookup. But yeah, I solved a way harder problem by accident because I don't know, yeah. But yeah, otherwise we can place a flower here, yay, and also increment by 1, and then now we just at the end return whether the total is greater than or equal to k. That's pretty much it. It is a really simple problem. So, but yeah, it's a little bit sad that I wasted a couple of minutes solving a harder one. Hope that Hope that explanation was good too, though. But yeah, so that looks good. It doesn't really, I think the only edge cases I have are where I have zeros on the edge. So I'm going to test that. I think we're okay on these, to be honest, but should be responsible. Let's click on the submit and hope that that's okay. Yep, looks good. So what's the complexity? Well, the complexity, we look at each item in flower bed at most 3 times from the left itself and to the right. Or another way to look at it is that we look at each, this loop only does like a set amount of operations, so it's going to be O of n. In terms of space, well, we do change flower bed in place, so that's maybe not a healthy. So you could say that's O of 1 space or O of n space if you want to copy it over so you don't change the input. And actually, you can still have O of 1 without changing the input by just keeping track of the last index you updated, because then you just have more cases on the if statements. But I was a little bit lazy with respect to this one, so my solution is the space complex is a little bit awkward, but you can definitely implement this O of 1. But yeah, and if you do think this problem is easy, definitely feel free to upsolve it using or like where the case is that you have okay, like you cannot have like for example here, as I was kind of describing the solution already for, so maybe you can have an idea. You cannot have any flowers 3 to the left and 3 to the right or something like that, right? So those are the upsolving problems that I would have for you to practice, and it probably is another Leetcode problem, to be honest. And if you know what that problem is, link it in the comments. But that's all I have for this problem and for today. I will see y'all tomorrow. Bye bye.